Alrighty, folks. Today we are going to be talking about electric power and energy. So let's go ahead and get started. All right, first off, announcements. The material for today and tomorrow comes from the packet. We have a note sheet and a couple of worksheets that we're going to be using. So please make sure you either have a printed copy of the material or access to the digital versions. Those are in the Schoology folder for electricity, and I will have the notes and the individual worksheets listed in today's folder and tomorrow's folders as well, so you can access them there. All right, today's notes setup is real straightforward. I want you to find the notes page labeled B.4.1.N, electric power or electric energy and power notes. It looks like this. So go ahead and pause the video, find that sheet, and make sure you have it ready to go. You can either write directly on it, or you can take notes on a piece of paper and refer back to this sheet. All right, our learning targets for today are I can calculate electric power and I can calculate electric energy. So, electric power, this is how fast energy is released by an electric circuit. And the electric power is a measurement of the rate at which energy is used over a period of time. So, the metric unit that we use for power is something known as the watt, which is shorthand for joules per second, and it is named after James Watt. We have a nice little picture of him right over here. All right, so calculating electric power actually is pretty straightforward. We use a couple of variables and measurements that we are already familiar with, and those are voltage and current. So our formula for electric power is voltage times current equals power, or V times I equals P. Over here, I have a power equation triangle for you, so please feel free to add that to your notes. As always, you should be familiar with how to use the power equation triangle. If not, you can, or just formula triangles in general. If you have questions about that, please feel free to ask. All right, so on your notes, we have an example of an electric power problem. So let's go ahead and talk about how we would do this. So as we said before, power, which is measured in watts, is equal to voltage, measured in volts, times current, which is measured in amps or amperes, A. All right, so our question is, a DVD player uses 0.21 amps of current when plugged into a 120 volt outlet. This is when it's not being used. How much power does the DVD player use? All right, so first thing we're going to do is we're going to identify the information that we were given. So our current is 0.21 amps. That's given to us right here, so we'll write that down. And then we are given the voltage, 120 V, or volts. So V equals 120 V. If we use our power formula triangle, we would cover up P, and that would leave us with current times voltage, and therefore P equals current times voltage. Current is 0.21 amps, voltage is 120 volts. 0.21 amps times 120 volts is 25.2 watts. So make sure that you have that down in your notes for problem number 1. Feel free to pause the video or go back over this if you need to, but we're going to go ahead and move to the next part. All right, electric energy is the next thing that we're going to talk about, and this is electricity's ability to do work. This is used by utility companies to determine how much electricity a customer is using, and it is measured in a unit called kilowatt hours, or kWh. Now, the important thing to know is that when we calculate electric power, we calculate it in watts. However, electric energy is measured using kilowatt hours, so we're going to need to convert watts to kilowatts. So we need to remember that there are 1,000 watts in a kilowatt. So let's really quickly go over how you convert between watts and kilowatts. So 1,000 watts equals 1 kilowatts. So you can do this a couple of ways. Number one, you can take the decimal point at in the watts, which in this case is here, and move it to the left. 1, 2, 3 places. If you move the decimal point 3 places to the left, that will give you the number of kilowatts. Or you can take the number of watts and divide it by 1,000, and that will give you the number of kilowatts. You will need to do one of those two operations if or whenever you are figuring out electrical energy. So please make sure that you are familiar with that. I will prompt you to do that on any sort of quick quiz that we have. All right. So electric energy is going to be determined by multiplying power by time. So electric energy, E equals power, P times time, T. This actually makes a lot of sense with the unit, which is kilowatt hours, because kilowatt hours equals kilowatts times hours. Kilowatts is a power unit, hours is a time unit. All right, so here's an example of an electric energy problem. So I would tell you something, for example, that an Xbox has a power rating of 150 watts. So the first question that I would ask you is how many kilowatts is this? So you would take this information of 150 watts and write it down, and you would either take the decimal point and move it 1 to 3 places to the left to get 0.15 kilowatts, or you would take 150 watts and divide it by 1,000 to get 0.15 kilowatts. Both ways will give you the same answer. All right, so that's how we solve part A. Part B is going to be if the Xbox is used on average 2 hours a day, how many kilowatt hours are used? Well, in this example, our power is given to us as 0.15 kilowatts. We figured that out from the previous part of the problem. And our time is given to us right here at 2 hours a day. So T equals 2 hours. So we have a formula triangle for this that we can use. Energy equals power times time. So energy is what we're trying to find, and that would be power multiplied by time. Our power is 0.15 kilowatts. Our time is 2 hours. 0.15 kilowatts times 2 hours equals 0.30 kilowatt hours. Go ahead and make sure you have that completed in your notes, that you understand it. Feel free to pause this and rewind it and go back over it if you have any questions on that. All right, so now that we have this information, we can actually do what is called the cost of utilities. So cost of utilities is measured in kilowatt hours. So you can imagine this as kind of like gallons of gasoline. If you have when you fill up a car, you fill it up with gallons, and the gas station charges per gallon of gasoline that you use. The electric company, for example, Xcel Energy, they are going to charge you based on the number of kilowatt hours that you use. The cost is going to vary by location, season, and other factors. So, for example, in 2016, the cost of 1 kilowatt hour varied. In the United States, the highest was Hawaii at 23.87 cents per kilowatt hour. Louisiana had the lowest cost of kilowatt hours at 7.46 cents per kilowatt hour. On average, it was about 10.27 cents, and Minnesota was just below average at 9.99 cents per kilowatt hour. So for each kilowatt hour you use, you owe the utility company that much money. So we're going to use that to figure out how much our electricity costs. All right, so in order to do that, you need to first calculate the electric power, and then you will or the cost of electricity. You calculate the electric power, then you multiply by time to get the electric energy, and that energy is going to have a cost associated with it, so you'll use that. So let's look at an example problem going off of our Xbox example. The average cost per kilowatt hour is $0.109 or 10.9 cents. We'll just be using it in the dollar form for these problems. What is the cost to use the Xbox on an average day? The energy used is 0.3 kilowatt hours. We figured that out from part B of the problem. The cost is going to be $0.109 per kilowatt hour. Our daily cost is the cost, or the amount of energy, E, times the cost that we just laid out, $0.109 per kilowatt hour. So if we multiply those together, 0.3 kilowatt hours times $0.109 per kilowatt hour cancels kilowatt hour, and you end up doing zero point 0.3 times $0.109, and that is going to give you 0.0327. If this were your final answer, you would just round that to 0.03. I will be very cognizant or aware of the fact of rounding is taking place when you enter these hours or these numbers into Schoology. So just kind of try to keep them as whole as possible, depending on what you're calculating. All right, go ahead and pause the video. Make sure you have all of that completed. If you need to, go back and watch that again. If you have questions, we will take questions later on. All right, so at the end of your notes, you will see that we kind of put all of this together. So the cost of using a utility. We have a problem on here that is a hairdryer has a rating of 1,875 watts. And the questions that surround this are, how many kilowatts is this? The hairdryer is used on average 15 minutes per day, which would be 0.25 hours. How many kilowatt hours, kWh, are used? The cost per kilowatt hour is $0.109. What is the cost to use the hairdryer on an average day? And how much does it cost to use the hairdryer each year? Remember that there are 365 days in a year. This is on your notes sheet. If you wouldn't mind, go ahead and pause the video and see if you can solve this example on your own, and then unpause the video and we'll walk through how to do it. Alrighty, so here we go. I've tried to color code this as much as possible. All right, how many kilowatts is this? So first off, we start out with 1875 or 1,875 watts, and you can either divide it by 1,000 or move the decimal point to the left 3 places. Either way, you will end up with 1.875 kilowatts. All right, so that is our number of kilowatts, or the power. After that, we are solving for the amount of energy. So we have our power at 1.875 kilowatts. We have our time, which is given right here as 0.25 hours. Energy is what we're solving for. That's our unknown. So we use our formula triangle, and we find out we're multiplying power by time. Energy equals power multiplied by time. Our power is 1.875 kilowatts. Our time is 0.25 hours. This equals 0.46875 kilowatt hours. Next, and we're going to want to keep that number, all of those decimals, because we are continuing on in the problem. The cost is going to be $0.109 per kilowatt hour. The amount of energy we use, we just figured out up here, 0.46875 kilowatt hours. The daily cost is going to be your energy multiplied by cost. Your energy, as we said, is 0.46875 kilowatt hours right here. And your cost is $0.109 per kilowatt hour right here. You multiply those together, you're going to end up with a daily cost of $0.0511. Now, the yearly cost, all we are going to do for that is take the daily cost and multiply it by 365, which is the number of days in a year. So you have 0.0511 times 365. You multiply those together and you will end up with $18.65. All right, folks, so these are our examples. I know that there's a lot of math here and we kind of stacked everything on top of each other and went through a lot. So hopefully that made some sense, but I also understand that some of you are going to need a little bit of help. I am available during office hours today, so please, please, please feel free to come in and ask clarifying questions. I'd be very happy to walk through any of these examples with you, give you new examples, give you different ways to look at this. So please bring your questions to office hours. As always, also, please make sure that you're posting questions in the question forum so I can kind of know some things to clarify going forward.